This diagram is called a pedigree. A pedigree is one way to trace a trait through families and to find out what kind of inheritance that trait has. Some things to know before we start are that all of the zeros or all of the circles represent females and all of the squares represent males. Anything that is colored in shows the trait that we're studying in that pedigree. Any person that is not colored in does not show the trait that we're looking at in that pedigree. You can always look over to the left side usually for the generation number. So you start up at the top with your first generation, and then your second generation, third generation, fourth generation, and the fifth generation. A line in between two individuals represents a marriage. For example, up here in generation 1, this male has the trait, this female does not have the trait. So they had 6 kids. 5 of them are girls and 1 boy. None of their children show the trait. And then one of their daughters married this man over here and had 5 children. Whereas this daughter over here married this man and they also had 5 children. So all of these lines that go this way represent marriage, and anything that has a down line and then branches like this is children that were produced by 2 of the same people. So when I look at this trait, I'm going to take a look at letter A here. On the basis of this data, which of the following mechanisms of inheritance are possible? It appears that this might be a recessive trait. The reason I think it might be recessive is because if we look over here in generation 2, these 2 parents don't have that trait. But then they have 2 sons that have this trait. I see the same thing happening over here in generation 4. They don't have the trait, but then all of a sudden their children have this trait. Over here, don't have the trait in either parent, child has the trait, and we see that continue in 2 other families. Let's see, it might also be sex-linked recessive because what I'm noticing as I study this pedigree is that it really is only showing up in males. All of these affected individuals are male and none of the females appear to be affected. So for B here, I think that I would go with sex-linked recessive. And remember that sex-linked recessive means that it is carried on the X chromosome and that females will be XX while males will be XY. So when I look at letter C, what is the genotype of female A? So that is this one right here. So female A got an X chromosome from her father who would have been affected by this trait. So female A's father's genotype probably was recessive like that. And then she received this X from her father and one of the dominant non-affected traits from her mother. So female A's genotype is heterozygous for that trait. And I know that her genotype is heterozygous for that trait because she has a son that shows that trait down here. So she must have given this allele to her son. For letter D, I would say that this guy's genotype is going to have to be the dominant unaffected allele because none of his daughters show this trait, and we also see that his box is not colored in. And if this is a sex-linked trait, he only has one copy of that allele, so he has the dominant unaffected allele. Now for letter E, like we talked about, it is possible for a female to have a sex-linked trait, but because they have the two X's, it's less likely. But in the case of marriage C producing a daughter that has the I defect, there is a potential that this mother is a carrier. So if she is a carrier for this trait because she inherited that allele from her mother, and the male over here, we can see that he does have this trait. So when I do a Punnett square for those two, erase that, I see that we have a little bit more potential here for more children to have this trait. So in this case, it is actually 50% of the females from that pairing would have the recessive trait, and 50% of the males from that pairing would have the recessive trait.